Welcome to Learn Yourself. Today we are going to study the periodic classification of elements. This chapter is under CBSE Standard 10 syllabus. So let us start our chapter from Doberainers triad. So here we are going to discuss 4 scientists in total. First is Doberainer, then Newlands Octaves law, then Mendeleev's periodic table, and then Mendeleev's periodic table. So all this were the concept at that time, and from that today's modern periodic table we have derived. In previous chapter we have studied that so many scientists have given their own concept with their own structure of atom. Those were the concept, and we have studied that how they have given or how they have proposed their structure of the atom and why those structure were failed, and how we have come up with today's new and correct structure. Similarly, we are discussing how today's new modern periodic table has been derived. So that we will study from 4 scientists. First is Doberainers triad, then Newlands Octaves law, then Mendeleev's periodic table, and the last modern periodic table. So here we are starting with Doberainers triad. In this you have to study 3 things. First, how they have arranged the elements. Second, the concept behind their arrangement. And third, what are the limitations for their arrangement or whatever arrangement they have given for the periodic table. So Doberainer was a German scientist, German chemist, who tried to arrange the elements with similar properties into group. So he tried to arrange whatever elements have been discovered at that time. Those elements he tried to arrange in specific groups. Groups were 3 elements in each, and that's why it was known as triads. Because in each group he placed 3 elements. So that's why it was known as Doberainers triads. How he has arranged this? In order of increasing atomic masses. The atomic mass of middle element was roughly average of the atomic masses of the 2 other elements. That means this was Doberainers triad, and in that he placed lithium, sodium and potassium, such that lithium and potassium's average, if you will take out, then and it will be roughly near to sodium's mass, and that is how he arranged 3 triads and total 9 elements. Again, he arranged 3 elements in such a pattern that if you will take average of 2 elements at each side, then you will get an answer, the atomic mass of, and that is roughly equal to the atomic mass of the middle element. So that is how he arranged these 9 elements. But he gave only 3 triads, and he has arranged in order of increasing order of atomic masses. This is increasing order, that from this atomic mass is more, and from this atomic mass is more. So that is how Doberainers arranged 3 elements in one group. Another 2 triads he gave, that was calcium, strontium and barium. This was another triad, the second triad, and the last triad he gave was of chlorine, bromine and iodine. So this was the 3rd triad. So this is first, this is second triad, and this was the 3rd triad. In total he arranged 9 elements in 3 triads. Now moving towards the limitation of Doberainers triad. So these were the limitations of Doberainers triad. First is, method was not holding true for all the elements. He gave triads for only 9 elements, into that 3 triads. So it was not holding true for all the elements. Only some of the elements, only few elements he could arrange in this triad pattern. The second point is, properties of elements of group into triads were found not to be similar. So some of the elements which he has placed into triads, their properties were not matching with each other. He has only focused on to arrange element in increasing order of the atomic mass, and he has arranged us that middle element will be an average of the other 2. But rest two important criteria were not hold true for Doberainers triad. So these were the main limitations of Doberainers triad. This is the second law. In previous video we have studied about Doberainers triad. Here the Newland was the scientist and he gave the law of octave. So why this law's name is octave? Let us see that. He started arranging from hydrogen to thorium, and at that time only 56 elements were there, or only 56 elements have been discovered. So he arranged all these 56 elements in his arrangement, and it was starting from hydrogen to thorium. And he found every eighth element has same property as first element. When he was arranging, he discovered that when he is arranging all these elements, that 1, 2, 3, 4, 5, 6 and 7, after this 7th element, if he will put the 8th element here, then these two elements properties are similar to each other. That was his finding through this arrangement. Again, he found every 8th element. So he arranged 7 elements in line like this, and he discovered that the 8th element, whatever he is getting, that 8th element has a similar property to that of the first element. That was his finding through this arrangement. He compared this to music octave. We know that musical notes sa, re, ga, ma, pa, da, ni, sa, and he compared this with musical notes, and that's why this law was known as Newland's law of octave. Now for example, he arranged like this, that hydrogen, lithium, beryllium, boron, carbon, nitrogen and oxygen. After that, the 8th element, fluorine, he placed below hydrogen, and he found out that the 8th element is possessing the same property as the first one. Now what were the limitations of this law? That this law was only applicable till calcium, and we can also say that this law was hold true for light elements and only up till calcium, and beyond that for the heavier elements this law was not hold true. Then only for 56 elements, he arranged only 56 elements because he thought that only 56 elements are there. He did not keep any space for the elements which elements were about to discover in the future. Third one is cobalt and nickel he arranged in same slot. In one column he arranged cobalt and nickel like this. Cobalt and nickel he arranged in one slot. At one place he arranged both of them, and that is under fluorine and hydrogen. Now fluorine and hydrogen, this we are talking about this first column. So after hydrogen he placed fluorine, and after that he placed cobalt and nickel. So this element's properties are not matching with each other. So this was the biggest limitation of Newland's octave law. Then those properties were not same, and once the noble gases were discovered, after his law the noble gases were discovered, and with the discovery of noble gases the Newland's octave law was irrelevant with all the arrangement, because he did not keep any place for new element, and when the noble gases were found out, then they need to arrange them in separate slot according to their properties. So that arrangement was also not there in his arrangement. So this was the Newland's octave law. He arranged elements in increasing order of their atomic masses, and he tried to arrange in specific arrangement so that the first element's property will exactly similar to every 8th element. But there were few limitations of Newland's octave law, and after noble gases discovery this law was irrelevant and was not hold true for many elements. So Mendeleev's periodic table or periodic law, whatever he has designed, and he arranged 63 elements. So at that time 63 elements were known and he arranged according to their property. And as a base, what he took a compounds formed by elements with hydrogen and oxygen. For example, any compound like fluorine. So he found out that fluorine will make which kind of compound with hydrogen. Fluorine will make which kind of compound with oxygen. What are the fluorine hydrides and fluorine oxides are there, and he gave a specific formula to that, and he took out some of the elements which are making the similar compound which has a similar molecular formula, and they all have similar physical and chemical properties. So this is how he arranged his periodic table, that here he has written the molecular formula from oxide and hydride. This is oxide formula. So all this group, he called all the horizontal columns a period and all vertical columns a group. So the first place he gave to hydrogen. So here R2O, that means hydrogen oxide's formula is H2O. R means whatever element he has placed here. Here RH, that means R is again a hydrogen, that is this element, and H is hydride. So when hydrogen will form a hydride, then it is 2H, that means H2. So that is how he wrote all the molecular formula here. For the second group, he wrote formula that RO and RH2. For example, here he placed Be. So when beryllium we are taking, the formula of beryllium with oxygen is BeO and with hydrogen is BeH2. So that is how he arranged all the elements according to how they are making hydride and oxide. So what he found out that there are some similar properties in the groups and in the periods, and he gave the name groups, columns, periods and all. Then he arranged in order of their increasing atomic weight. What was the base of his arrangement? Was atomic weight, atomic mass. He arranged in order of their increasing order of their atomic mass. He also observed that there was a periodic reoccurrence of physical and chemical properties. He also observed via this arrangement that these physical and chemical properties are reappearing after certain elements. And after that he gave a law, and this was known as Mendeleev's periodic law. The properties of elements are periodic function of their atomic masses. Periodic function means it is repetitive. As we are arranging them in increasing order of the atomic mass, these properties are repeating by itself after certain interval, after certain elements. They are repeating. That means the properties of elements are periodic function of their atomic mass. And when this will happen, when we are arranging elements in increasing order of their atomic mass. Now let us discuss some of the achievements of Mendeleev periodic table. So first is scientists have approved it. Scientists approved it, and this was the first periodic table which was hold true for all the existing criteria at that time. Second, noble gases placed in new group without disturbing existing elements. Noble gases were found very lately after Mendeleev's periodic table, but when they found out, they have been placed in Mendeleev periodic table, and that too without disturbing existing element, and they could arrange noble gases in separate group. Mendeleev predicted some of the elements based on the gaps in between. At that time some of the elements were not known, but through his arrangement, whatever gaps were there in between, he could predicted some of the elements, and those elements later found out. Some of the elements were like scandium, gallium, germanium, all these elements were found out because of the gaps remaining in Mendeleev's periodic table. So these were the achievements of Mendeleev's periodic table. So let us discuss the limitations of Mendeleev's periodic law or periodic table. So the first is there was no fixed position assigned to hydrogen. Mendeleev could not judge or could not decide the position of hydrogen because hydrogen has dual nature and it shows properties similar to halides also and similar to alkali metals also. So there was no fixed position for hydrogen in his periodic table. Second is no arrangement for isotopes because he arranged all the elements in increasing order of the atomic mass. So when we are talking about isotope, hydrogen has 3 isotopes. So with one element, he cannot give one element 3 different places. But if we can assign the places according to the increasing order of atomic mass, then we have to give 3 different places to hydrogen. But that is not correct when we are thinking about isotope. And isotopes have been discovered long after Mendeleev's periodic table. So at that time, Mendeleev's periodic table was not, this arrangement was not hold true for all those isotopes. Then third, atomic masses do not increase at regular manner. This is very important. They are increasing but not in regular manner. So wherever he placed a blank that this will be discovered in the future and this is the place for it, then at that time it was not possible to predict that how many elements can be placed or could be discovered in between the 2 elements because there was no certain pattern for atomic mass to increase. So these were few limitations of Mendeleev's periodic table, and all of this because of he has arranged periodic table according to their atomic masses. Earlier we have seen different periodic tables and those periodic tables were a concrete base for this today's modern periodic table. In that, Doberainers, triads, newlands, octave law and the most important Mendeleev's periodic table were there. So if you haven't gone through those videos, I have given those videos link in the description. Go through those videos and understand that how we have come up with this concept. So modern periodic tables law was properties of elements are periodic function of their atomic number. Earlier in Mendeleev's periodic table, this was atomic mass. He said that properties are repeating at certain interval of time when we are arranging elements as per their increasing order of atomic masses. Here we have arranged in modern periodic table, which has been given by the Mendeleev scientist. He suggested that if we will arrange the periodic table according to their increasing order of their atomic number, then we can eliminate all this limitation which we are facing in Mendeleev's periodic table. So this was the law of modern periodic table, that properties of elements are periodic function. Periodic function means at certain interval of time they are repeating, that after certain elements the element will come which has similar property to other element. That is the meaning of periodic function of their atomic number. Now in modern periodic table there were 18 vertical columns like this. This is our periodic table. This is how we have arranged like this. So here we have placed all the metals. As we are going towards this side, in between the metalloids are there. What are the metalloids? Metalloids are the elements. Metalloids are the elements which shows the similar property to that of the metal and non-metal. So they have mixed properties of metal and non-metal. So those all elements are placed in between, and here all non-metals. So as we are going from left to right, the non-metal character in the element will increase. So as we are going from left to right, the non-metal character is increasing, and if we are going from right to left, the metallic character will increase. So in between these elements shows both the properties like metal also and like non-metals also. Now here, so all these are vertical column 1, 2 and up till 18. So all these are vertical columns and these columns are known as group. All these are horizontal rows and they are called periods. So here we have 7 periods in total and there are 18 columns in total, or there are 18 groups in total. We have placed hydrogen first and then here at the 18th group we have placed helium. This is K shell. So here the K shell is completely filled. Now in next period it has started from lithium and goes up till neon. So here L shell is completely filled. So that is how we have placed the element. Let us see and discuss it thoroughly. Let us see the arrangement. So here how many columns are there? So groups are 18. Total 18 groups are there. This is 1, 2, 3, 4. All these are transition metals. In between these are transition metals. Transition metals are also known as metalloids. So metalloids are possessing properties like metal as well as non-metals. All these are metals. Towards this side all are non-metals. And the last one, this group is for noble gases. So all these are noble gases. So when we are going from left to right, the non-metallic character of element will increase. Now let us first understand that how they have arranged. So first we are taking hydrogen and then helium. In first period, these all are periods. All the horizontal rows are known as periods. So in first period, there are two elements, hydrogen and helium. If we will see their atomic number 1 and 2. So this is 1 and this is 2. If we will arrange them in electronic configuration, then hydrogen is 1 and helium is 2. So this is all about K shell. So first shell. So first period is all about K shell, and when this period will end, the K shell is completely filled. One electron and then second electron. So it is increasing in number of electron also while we are going from left to right. Let us see that in next period. So this is second period. So here it is lithium. It is third element, and from here the L shell will start. Here K shell is there, here L shell will start. So here in L shell, the K shell is completely filled. If we will write the electronic configuration, then it is 2 and 1 because 3 electrons are there. So that is how we are writing. Now after beryllium. So beryllium is 4. How many electrons are there in that? 4. So let us write its electronic configuration 2 and 2. So if you will see here that in L shell 1 electron has been increased as we are going from left to right. Let us take next element, that is boron. Boron is 5. So K shell, L shell. So here 2 and here 3. So the in L shell 1 electrons are increasing. Let us take oxygen. If you will check for carbon, then K shell, L shell 2 and here 4 will come. Then next nitrogen, it will be 2 and 5. Then oxygen, it will be 2 and 6. Then fluorine, it is 2 and 7. And here neon, it is 2 and 8. The L shell is completed here. So as we are starting from the first element, so 1 electron, then 2 electron, 3 electron, 4 electron, 5 electron. So as we are going from left to right in one period, then one electron is being added to the same shell. So here this is our atom and this is our shell. So this is first period where this K shell is completely filled. This is second period where L shell is completely filled. So one electron is being added to the same shell. Now let us check about the third period. Now you can guess this, that which orbital is being filled in this period. So here it is M shell. So M shell will start because here at neon L shell is completely filled. After that, if you have any electron, then definitely you have to put it in M shell. So let us check for M shell. So here I am writing third period. So in this, sodium is there. Sodium's electronic number is 11 and configuration is 2, 8, 1. If you have noticed, then K, L and M. M shell has been started here with the first element of third period. And when we will reach here at argon, the third shell will be completely filled because there are 18 electrons. So 2, 8 and 8. As we are going from top to bottom, the one shell is being added up. Here K shell, then L shell, then M shell. So as we are going from top to bottom, one shell is being increased, like 1, then 2, then 3. Where you can see this trend as we are going down groups. As we are going down groups, we can see this, that one shell is being added up in the element. Now as we are going from left to right within the same period, then one electron is being added up in the same shell. Here the second shell. So in this only one shell is there. So one electron is being added up in the same shell. And in third, the L shell. So one electron is being added up in third shell. So from first element, that shell will start with 1 electron. And with last element, that is a noble gas. So for that orbital, that will be the last electron. That's why the noble gases are at the last. That is how they have arranged the modern periodic table. And it is according to the increasing order of their atomic number. So in this, 3 points you have to remember. First, we have to arrange the element in increasing order of their atomic number. You have to remember the law of modern periodic table. Second, how the orbitals are increasing. In one period, only electron is being added up in same shell, and in group, one shell is being added up in the element. Then the next one is from left to right as we are going, the metallic character will decrease, or you can just remember the position of the elements, that towards left side all the metallic elements are there, towards the right hand side all non-metallic elements are there, and in between metalloids or transition metals are there. The periodic trends in atomic size. Earlier we have discussed modern periodic table, and in that we have discussed how we have arranged all the elements according to their increasing order of their atomic number. That means I have mentioned here 3 periods. First period, second period and third period. So till 20 we have to remember all the elements' name, their atomic number, their electronic distribution weight and their valencies, and which kind of ions they will generate, whether they will generate positive ion or negative ion. All those information we can derive from atomic number and electronic distribution. If you have any doubt regarding any of this concept, then please check my previous videos based on valency and combining capacity, video about modern periodic table. Then only you will get to know that how we have arranged element in specific way. Then come back to this video. In trends category, we are going to learn the specific pattern of elements. If we are choosing the atomic size, then whether atomic size is increasing or decreasing across the period or across the group, then we will see that, we will understand that, and we will understand the scientific reason behind that. That why this kind of certain pattern we are observing in periodic table when we are arranging them in increasing order of their atomic number. Trends means a certain specific property of the elements which is repeating after certain elements, and we can see that it is increasing slowly while we are going from left to right, and it is decreasing slowly across the group. All these parameters we will study in trends. So in trends we are going to mainly study three trends. First is atomic size, then valency, then metallic and non-metallic character, and under metallic and non-metallic character we will also study the losing of electron. So all these trends we are going to study in coming videos. Here today we are going to discuss about atomic size. So the first thing is we have to understand how we have arranged the elements in our periodic table. So this I have mentioned here three periods, and in this is a first period, this is a second period, this is third period. Now we know that what all horizontal lines are there, we term them periods, and what all vertical lines or vertical columns are there, we term them as groups. So here I have mentioned three periods and total 8 groups I have mentioned here. Here we have not included metalloids and we have not included transition metal elements. So in the first period, the one electron is there, that is for hydrogen, and that period will be completed with helium. So in first period there are only two elements, hydrogen and helium, and with this our K shell is completely filled. We know that we have 4 different orbitals, and what are their capacities? K shell's capacity is 2, S shell's capacity is 8, and M shell's capacity is 18, but we cannot put more than 8 electron in outermost shell. So in turn, in M shell we can put maximum 8 electrons. So here this we are talking about first shell, that is K shell, and it is completely filled when the first period will get over. This is our element, and in first K shell 1 electron is there, and when we reach here in helium, in first K shell there are 2 electrons. So outermost shell is completely filled in first period. Now coming back to second period, here the second orbital has started because the first shell is completely filled. Now we are coming here in second orbit. So in second orbit 1 electron is there. So here 1 electron I am mentioning in second orbit. As we are going towards right hand side, here let me put 2 electrons. You can see here that as we are going from left to right, the 1 electron is being added to the outermost shell. So here the K shell is completely filled. So we have to put electron in L shell. Now here in L shell, lithium's atomic number is 3. So 2 and 1. We have kept here 1 electron. Going forward, here the beryllium's atomic number is 4. So we have kept here 2 and 2. So slowly, one by one, valence electrons are increasing. You can see here as we are going from left to right. and that we are keeping in valence orbital. Now what is the meaning of valence orbital? The outermost shell of element is known as valence orbital, and the electrons present in the valence orbital is known as valence electron. So this L shell is completely filled when we will reach till noble gas. This is neon, this is noble gas, and there are 8 complete electron in L shell. So here if we will draw a structure of neon, then it is something like this. The 8 complete electron will be there. So there are 8 electrons in neon and L shell is completely filled. So as we are going from left to right, one electron is being added to the same shell, to the valence shell. So here I am writing one electron is added to the same shell. This is important. This is the trend. As we are going from left to right, one electron is added to the same shell. Now here let us check the behavior in third period. So here the L shell is completely filled. So now if we want to put more electrons, then we are going to the third shell, and that is M shell. So here if we are drawing an orbital structure of sodium, then it is something like this with 3 orbitals, and in third orbit 1 electron is there. So here the valence orbit is M shell. Here when we will reach at the last element, the complete M shell will be filled. Let us see how. So see this. Here first 2 shell is completely filled. So for sodium there are 11 electrons. So I have kept 1 electron in its valence shell, that is the last shell M. As we are going from left to right, one electron is being added to the valence shell, and once we are reaching till argon, the valence shell is completely filled with 8 electrons. So here the K shell has started, it is completely filled with helium. Here the L shell has been started, and that is completely filled once we are reaching at noble gas. And here the M shell has started, and M shell has been completely filled when we are reaching till argon. So here also the one electron is being added to the same shell as we are going from left to right. Now what about the atomic size? So as we are going from left to right, the atomic size will decrease. Why it will decrease? Because see here, in same shell the electrons are being added up. So what will happen when we will go from left to right? The more electrons and more protons are coming in atoms. So the more number of electrons when we are adding in the same shell like this. In the one shell we are keep on adding more and more electrons. So when we are reaching towards the right hand side, the more electrostatic force will be there and nuclear charge will increase from left to right. So the nuclear charge will pull the electrons towards the nucleus. So the atomic size will decrease as we will go from left to right. What is the reason behind that? As we are going from left to right, one electron is being added to the same shell. So the nuclear charge will increase. As the nuclear charge will increase, the nuclear charge will pull electron towards the nucleus. So the atomic size will decrease as we will go from left to right. Now let us see the pattern. What will happen when we will go from top to bottom or across the group? What we have discussed is from left to right, or we can also say that this is across the period. So across the period the atomic size will decrease. That also means that the size of nitrogen is smaller than the size of carbon. The size of oxygen is smaller than the size of nitrogen. That is the meaning of across the period and while going from left to right. Now let us study the pattern of atomic size while we are going from top to bottom or across the period. Now you can see here that one electron is there in valence shell in one particular group. Let us take this one group and this is our second group. So we are taking this group first. So here one electron is there in valence shell, one electron is there in valence shell, and here also one electron is there in valence shell. Let us check the second group. 2 electron in valence shell, 2 electron in valence shell. That means when we are going top to bottom, what will happen? That we are keep on adding up the orbitals and the valence electron will remain same. See here, only one orbit, but the valence electron is 1, valence electron is 1, valence electron is 1. But here one orbit is there, here 2 orbitals are there, and here 3 orbitals are there. So as we are going from top to bottom, the orbitals are added up. We are adding one orbit to the element, but the valence electron will remain same. The orbitals which are inside, they are completely filled. So we are here focusing on valence electrons. So the valence electron will remain same across the group. And we are adding one orbital to the element as we are going from top to bottom. Now here what will happen? As we are going from top to bottom or across the group, the atomic size will increase. Why atomic size will increase? Because here we are keep on adding up the orbitals. So the distance from the nucleus will increase continuously as we are going from top to bottom. Here also the nuclear charge will increase because electrons are increasing. So nuclear charge will increase, but the distance will overcome this nuclear charge. So across the group, the atomic size will increase. And while going left to right or across the period, the atomic size will decrease. Let us write this in point-wise manner and understand this. So let us write this way and compare what will happen across the period and across the group. Across the period means left to right horizontally, and across the group means top to bottom and through the vertical column. Now here when we are going from left to right, what will happen? The one electron is being added to the same shell. Here like this. If 1-2 shell is there, in second period I am talking about, then as we are going from left to right, we are keep on adding in one shell all the electrons one by one. Across the group what will happen? The valence electron will remain same, but one orbital will be added. So like this. Here if we are talking about the first group, then here. So one shell, one electron, 2 shell, the 1 electron as valence electron, and at the third element what will happen? 3 orbitals will be there, and in the last shell 1 electron will be there. So valence electron will remain same, but one orbital will be added. So here it will be K shell, and then L shell and M shell will be there. Here we are talking about the valence shell. So this is the basic difference between across the period and across the group. Now what will happen to atomic size? As we are going from left to right, the nuclear charge will increase, and as a result the atomic size will decrease. Now why it will happen like that? Because the nuclear charge will pull electron towards the nucleus. So that's why atomic size will decrease. Now what will happen across the group? Top to bottom, nuclear charge will increase. Nuclear charge is there in across the group also, and it will increase also. But along with that, as I have shown here, the distance from the nucleus will also increase. So that distance will overcome the nuclear charge. So that this is important point, that distance will overcome the nuclear charge and atomic size will increase. So as you are going from top to bottom, the atomic size will increase, and as you are going from left to right, the atomic size will decrease. So what is the valency? Valency is electrons present in outermost shell. So we are learning that K, L, M and N shells are there. So we are in our syllabus till this 4 shells are there. So in this the capacities are 2, 8 and here 18 and 32, but what we are keeping is 8 and 8. So if the outermost shell has 1 electron, then the valency of that element is 1. If the outermost shell has 7 electrons, then it is lacking by 1, so it will accept 1 electron. In that case also the valency of that element is 1. So let us see here the electronic configuration of elements. So hydrogen is 1, helium is 2. So here the K shell is completely filled. Now with second period, lithium is starting with L shell. So 2, 1. Here the L shell has been started and 1 electron in this. So this 1 electron will be valency of lithium. Now here beryllium. So 2 electrons are there. So 2 electrons are the valence electrons of beryllium. So how many electrons are there in outermost shell? 2. This is outermost shell. This is inner shell. So here 2 electrons are valence electron. Here for boron 3 electrons, carbon 4, nitrogen 5, oxygen 6, fluorine 7, and for neon valence electrons are there. If you have seen here that in L shell the continuously 1 electron is being added up in valence orbital. Last shell we can also say valence orbital because all these electrons are valence electron for this element. Now from the valence electron, how to decide valency? For that you have to check my video based on combining capacity, valency and bonding. How can we decide the valency of an atom? That video you can check under the playlist Basic Concepts of Chemistry. If you have any doubt in valency or how to decide valency, please go through that video. So here these are the valence electron, this is the valence shell. Outermost shell is valence orbital, and how many electrons are there in the shell will become the valence electron for this element. Now here when we are talking about M shell in third period, so here it has been started. So here 1 valence electron is there. So here 2 valence electron are there. So M shell is valence orbital for this third period and L shell is valence orbital for second period. Now when this period will end, it has complete 8 electron in M shell. So 8 electrons are valence electron for argon. Now if you have noticed that as we are going from top to bottom, the valence electrons are remain same in the last shell. Only one shell is being added up. So if I will represent this trend in orbital structure, then this is one shell and it has 1 electron. In valence shell there is only 1 electron. Here 3 orbitals will be there, K, L, M, and in M shell 1 electron is there. So 1 orbital is being added up here, and in the last shell 1 electron is there. So here the valence electron will remain same, 1, 1 and 1. Similarly we can see for the second group as we are going from top to bottom. So in second shell there are 2 electrons, in third shell there are 2 electrons, and in next element, fourth orbital, it will also have 2 electrons like this. So here also 3 electrons, 3 electrons and 3 electrons, but 1 orbital will be added up. And while we are talking about the period, so here this orbital will be there, but in this orbital 1 electron is being added up. Here 2. Then here if we are talking about 1, 2 and 3. Then here 1, 2, 3 and 4. And at the last what will happen? That there are 1, 2, 3, 4, 5, 6, 7 and 8 electrons. So same shell will be filled up while you are reaching at the noble gases. And here this will be the trend that 1 orbital will be added up in the element, but the valence electron will remain same. Here 1 valence electron will be increasing as you are going from left to right. So this is the basic difference while we are arranging elements in groups and in periods. Let us understand all the trends together for modern periodic table. This topic is under CBSE Standard 10 syllabus. In previous videos we have discussed about valency, then atomic size, metallic and non-metallic character, all these trends across the period and across the group. Now let us understand that how to remember that along with their scientific reason. So here this is a kind of flow chart I have made it, and here these points are for valence electron. So these are group 1 and group 2. So across the group the valence electron will remain same. As you are going down 1 orbital will increase, but the valence electron will remain same. So here in the first period it will be K, then L, then M and N. So this one electron is in K shell, this one electron is in L shell, and so as here this one electron in M shell, and inside all the orbitals are completely filled. Here similarly for group 2, that 2 electrons will be there in their valence shell. So valence electron will remain same across the group. Now when we are talking about period, so it is only for one shell, and this is first period is for K shell, second period is for L shell. So in one particular shell 1 electron is being added up until that orbit will be completely filled with 8 electrons. Last will be noble gases. So here 1, 2, 3, 4 and 8. So complete 8 electrons will be there. So across the period all the electrons are being added up in same shell. So this you need to remember, that here the same shell 1 electron is being added up. Here orbitals are being added up, but valence electron will remain same. So this is across the group, this is across the period. Now we are talking about atomic size. So atomic size towards left to right, the atomic size will decrease. Why it will decrease? Because 1 electron is being added up in the same shell, and the nuclear charge, I am writing here NC, the nuclear charge will increase. So that's why the atomic size will decrease. The electrons are being pulled towards nucleus. So that's why the atomic size will decrease. Whereas from top to bottom or across the group, atomic size will increase, because 1 orbital is being added up. So from here K, L, M and N. Here also nuclear charge will work, but the distance will overcome the nuclear charge. That is important point, and that we have to mention. That distance will overcome the nuclear charge, and that's why the atomic size will increase. Now moving towards the second thing, that electron losing tendency. We know that metallic character from left to right it will decrease, and here all the non-metals are there. So electron losing tendency will decrease as we are going from left to right. And what is the reason for that? That the nuclear charge is more and we cannot pull the electrons with, it's not easy for us to pull out the electrons. Or we can write that as the non-metallic characters are increased towards the right hand side, they have more affinity towards electrons. So it is not easy to take out electron, or their tendency to lose electron will decrease as they are non-metals. Now from top to bottom the losing electron will increase because as they are moving far from nucleus, the nuclear charge will decrease and it is easy to take out the electron and electron losing tendency will increase. And here the metallic character will increase. So that's why electron losing from top to bottom will also increase. This we know that metallic character from left to right it will decrease and from right to left it will increase. And as we are going from top to bottom, the metallic character will increase. So these are some of the important trends in periodic table. This way you can remember all the trends along with its reason.